All right, so these students, these almost engineers, are very thankful for all the love and support that everyone has given them and putting them in the position of being able to be here today presenting their project. These young people came to university several years ago as freshmen, seeking to improve their lives and the lives of the world, the people in the world around us. And they're doing that by becoming engineers. Now, as seniors, they're just about ready to realize their dream. And we're sure you're going to be very impressed with their projects. The next project we have this morning is Cutting Edge Office Layout Application. Student presenters Christy Lyon, Jennifer McIver, Kyle Joslin, and Larry Fisher. It's all yours.
All right, can you see my screen?
Yeah. Okay, good morning, everyone, and thank you for joining our senior design presentation, where we will be discussing Steelcase in a cutting-edge office layout application. Here's a quick overview of what will be discussed during this presentation today. We will begin with the introduction and background information, then we'll move on to the project objective, overview, and need, then the project approach, moving on to Steelcase's One Design program, then data and research, including our analytical model, and then finally moving on to comparison and our recommendations for Steelcase to implement, and there will be time for questions at the end. My name is Jennifer McIver, and the other members of this team are Larry Fisher, Christy Lyon, and Kyle Joslin. Our company sponsors are Edward Vanderbilt. He is the Global Advanced Analytics Manager and Innovation Leader at Steelcase, and Jorge Lozano is a Data Science and Digital Transformation Leader. Shown here are our faculty advisors. Dr. White is a professor and IE PhD advisor, and Dr. Hushar is a professor and industrial engineering graduate advisor. We will be working with the Steelcase Kentland plant located in Grand Rapids, which happens to be its global headquarters. Steelcase was established in 1912 as a metal office furniture company. Now Steelcase brands offer a comprehensive portfolio of workplace products, furnishings, and services, where they also design spaces to help people work, learn, and heal. Some other retailers include West Elm, Wayfair, and Amazon. Steelcase understands how work and workers change and how that has changed the workplace itself. So therefore, they offer customers a portfolio of workplace services. They say it is about understanding the needs of your customer, exploring options, applying the right products, and ensuring your investment is delivered, installed, and maintained. Steelcase helps customers create the best office space for their needs. Our project scope is to assess the capabilities of Steelcase's One Design program using optimization and ranking analysis to help them create a single computer program that can also optimize an office layout. Our project overview is assigning areas to spaces based on customer inputs, optimize those spaces' locations according to their interdepartmental relationships, and then do proper furniture placement within that space. Steelcase has many types of communication zones or collaboration zones, and every single one of them differs from the other. A few are listed here. For example, the circulation area is an area for people to travel. The social zone would be a louder social area such as a cafeteria, while a focused workstation would be more of a private office or desk. The reason for this project is Steelcase needs an office layout optimization program for their customers that is user-friendly. As of now, it requires too many designers in multiple computer programs. It is costly and time-consuming, and no single program does it all, which is what Steelcase is striving towards.
Based on Steelcase's current capabilities and what they'd like their program to do, our team developed an approach moving forward with the project. This is depicted here in this flowchart and will be broken down in the following slides. Step 1 is to input an existing floor plan and determine the file type to be used. Steelcase currently receives many different file types. These include PDF, JPG, and DWG files. Step 2 is identify boundaries and structural requirements. These consist of things like stairwells, columns, and walls. Fixed locations, which include bathrooms or circulation areas, things that don't change during the optimization. And industry standards, which we'll discuss more under research. Step 3 is identifying constraints. After some analysis and applying the facility layout optimization to an office setting, we determined there were 3 primary constraints to look at: the personnel flow, material and communication flow, and noise restriction relationships between departments. Step 4 is identifying the best optimization program or method to use. These include things like VIP, Craft, and CORELAP, some of them being in Microsoft Excel, which we'll discuss more under analysis. Step 5 is analysis. So first, we want to satisfy all constraints, then use the ranking method to determine the best optimal layout, and finally compile everything into a presentable so that Steelcase can apply it to their one design program. Steelcase's current capabilities are to input an existing floor plan and highlight a zone to perform this optimization in and apply all of their communication zones to. This utilizes the total square footage of all those zones within that highlighted area. Shown here is their zone calculator to calculate those total square footages. The customer will use this and input a total workspace of their floor plan and input values such as a desk sharing ratio, a workstation width and height, and then the calculator will output values for the total square footage of each zone. Shown here is just a calculation table that Steelcase uses for calculating those values. So finally, based on those percentages and total square footages, Steelcase has an algorithm they've developed to place zones and apply them to that highlighted area, but it currently applies the total square footage for the whole floor plan within that small highlighted area. Their future goal is to eventually determine furniture allocation within those zones and potentially create a 3D software for those areas. So we've researched a few ideas to help with the initial project. One of those being that floor plan input, determining the file type. Steelcase determined they primarily need a DWG file to work with their program, but a lot of these files have no dimensions on them. So we've taken the liberty to find a few programs that are helpful and can be applied to Steelcase's software, such as Measure Square, and they take a reference dimension such as a door width and output total square footage of the entire floor plan. And it also has image recognition software and can highlight empty areas between walls within that floor plan. The next idea is square foot standards. These include things like net assignable square footage per worker, bathrooms, and meeting rooms. An example is shown here with the total square footage required per number of occupants of a meeting room. The next idea is physical constraints. These can include image recognition software to address these. Image recognition uses convolution neural networks, and what this does is it looks at a pixel grid of the image or floor plan. And in this case, they'd be using RGB values such as black and white to determine between walls, borders, and images of the floor plan. And they would train this program to recognize and separate those areas. And fixed zones could then be applied to the floor plan based on these empty areas between walls, these fixed zones being bathrooms and circulation areas such as walkways and hallways.
So in order for our team to begin analyzing different methods and algorithms that can be utilized to place zones within this floor plan, our team needed some sort of an example problem, which you can see is currently plugged into our Steelcase calculator before you. And you can see here our net usable workspace for this example problem was 30,000 square feet. And based upon that, Steelcase's calculator was able to give us our recommended square footages for each of those different zone types that they typically use. So the first way we solved this problem was using two different by hand methods, the first being a graph-based approach and the other being space relationship approach. The benefits to both of these is that they utilize a relationship matrix or flow matrix. So there's a definitive reason to why these zones are being placed where they are. And it also gives a really good visual of the optimal placement very early into the process. But major drawbacks of this method is that it is hand-drawn, making the estimate accuracy not great, and it is incredibly time-consuming for the user to do. A more sophisticated algorithm we then turned our attention to was the CORELAP algorithm. And the benefits to this was similar to the previous by hand methods, is that it uses the relationship matrix, but it takes it a second step farther and it utilizes a placement sequence. This means that the zone with the highest relationship with every single other zone is placed within the very center of the floor plan, which you can see in the example layout is zone 4. Again, a drawback to this method, though, was that it was time consuming and it was still done by hand, even though we were able to put it into Microsoft Excel. So our team then came together in an attempt to try to automate this process for a user within Microsoft Excel. The first step to this being we needed some way to create that sequence that is determined based upon the relationships. And we successfully did that through a series of if statements and iterations within Microsoft Excel, which is shown in a summary table below. And then the second part of that was we wanted to place departments into a model using VBA within Microsoft Excel. Some benefits to this is that it would have been a completely automated process and relatively easy to follow for someone who is uneducated in the finer details of CORELAP or relationship matrices. But major drawbacks to this was that it was very time consuming for us to actually create this VBA program, and our team was uneducated in the coding language of it. And around this time as well, our scope changed with Steelcase, and they wanted us to take a deeper look into how to tell what floor plan was more optimized or somehow better than the next floor plan. So to do this, our team then started creating a more analytical model. And the first step to this was to define the different dimensions, constraint weights, and the relationships between different zones. The second step would then, it would output the results, including the constraint matrices, the weighted matrix, and the placement order sequence, which we would then be able to plug that matrix output data into VIP PlanUp, and using VIP PlanUp, we would then be able to optimize and analyze different layouts. So here we have a short video that takes a walk through our analytical model.
In our team's model, we focused on constructing a method to automate the process of creating relationship matrices for each constraint, as well as a final weighted matrix. Having these weighted matrices gives reasoning for the placement of each zone in respect to the relationships based upon the constraints addressed, such as noise constraints between zones, the personnel flow between each of them, and the material and information flow between each zone. For the model shown, the user will first define all yellow cells in the section shown. This includes the dimensions of the entire office floor labeled as net usable workspace. The area for each zone is predetermined for this model and uses Steelcase's zone calculator to compute these areas based upon many different factors such as head count and desk sharing ratio. Once the net usable workspace is defined, the user will then define the weights that they would like each constraint to encompass. Each weight represents how important of a constraint the user wants to prioritize over another. The higher the percent, the more important that constraint is. The user will then move on to the next section and define the relationships between each zone. Each yellow cell here holds a pull-down menu for which the user would then choose one of the relationships shown to the right. Each relationship type holds its own magnitude and directly affects the matrices given as output results. These magnitude values are able to be manipulated by the user but should be relatively similar to that of which is shown here. The process is done for each of the three constraints defined in this model. When all input cells have been defined, quantitative matrices will be formed. These are formed from the numerical values associated with that constraint value. Each of the constraint matrices are then combined and use their defined constraint weights to make a weighted quantitative and qualitative final matrix.
So the first comparison method we looked at was cost analysis, which most optimization softwares use. And this cost is determined by taking the distance between two zones and multiplying that by the relationship value within that weighted matrix. So the first case we looked at is assuming all 7 zones and the total square footage is inside that chosen area, just as Steelcase's current capabilities perform. And we use VIP PlanOp, an optimization software, to assess the cost of this layout. The cost is shown here based on all of that square footage for each zone being in that small highlighted area of the floor plan. That cost is $4,143. The next idea we looked at is assuming that highlighted area is only 1/8 the size of the total square footage of that floor plan. And we reduce down the area of each zone type to 1/8 of their size. As shown here, the optimized layout is actually the same as the previous layout. It's just reduced areas per zone, obviously, and it has rotated the optimal layout 180 degrees. The next comparison idea is adjacency scoring. What this does is it takes 2 touching zones and sums up the values within the matrix that associate between those 2 zones. So shown here, that value would be 24 for just the zones that are touching. And then it divides that by the total number of the total sum of the values within that matrix, which here is shown to be 55.8% for that layout. So then we looked at assuming that Steelcase could apply some image recognition software and determine which zones go within that highlighted area. And we assume that only zone 1, 2, 3, and 5 would go within that highlighted area and perform the optimization again. The adjacency scoring for this layout is 9 out of 11, or 81.8%. And this is because there were less zones applied, so the adjacency score would be much higher. This shows how optimizing based on certain areas can be better, but not comparing the adjacency scores of the floor plan as a whole.
A question that Steelcase wanted us to look deeper into was how much does a constraint actually need to be changed in order to physically change the look of the layout? So in order for us to investigate this, our team looked closely at zone floor, which was the collaboration enclosed area. And you can see its current constraint values are listed underneath flow, 5, 3, 3, 0, 7, and etc. -1 being that 4 and 6 do not want to be close to each other, and 4 and 7 with 8 meaning that they want to be close to each other. So the first iteration of this was our team started changing one zone in a positive direction, giving them a higher relationship, meaning that they wanted to be closer together. So the original layout for this was shown at the top, and the total area required was almost 42,000 square feet. And after several changes to that layout, you can see that it actually changes. Zone 4 moves more into the center of the layout, and the rest other zones surrounding it also change. Our team then did several different iterations of different combinations of changing the zones. You can see that we moved one zone up, 2 zones up simultaneously, 1 zone down, and 1 zone up and 1 zone down simultaneously. And on average, it took about 5 total value changes in order to affect a total layout change. This means that in order for Steelcase to actually implement a physical layout change, they needed to change the constraint more than just like one tier. It needed to be changed several tiers.
So lastly, something that Steelcase wanted us to look at was also the effects of changing the scale, which the magnitude for each relationship is supposed to be worth. So a picture of our model shown here, and in the blue box, that's what we will be changing in this analysis period. And we wanted to change the values in the yellow cells to the right of the relationships. So we conducted 2 tests in this analysis period. The first test looked at the constraint that wanted to put zones closer together, which we labeled as a no noise relationship, and we ranged this from 15 to 1,000. Our second test was focused on the opposite constraint that dealt with negative numbers and would try to force zones further and further away from each other. So we ranged this from -1 to -10. Looking at the first test, you can see that dealing with this no noise relationship constraint, even if we increased the magnitude at which that relationship's worth, it didn't affect the layout change, and it also didn't affect the area at which the layout boundary was. It stayed at 50,423 feet squared for each of the 4 iterations. Now looking at the second test, it was a little bit different. Because we dealt with this negative number, it was forcing zone 2 and 6, because it encompasses relationship, further and further away from each other. And even though it didn't change a whole lot from -1 to -5, it changed a lot more drastically in -10. And you can see that in these layouts, and it also, because of this, it creates a higher boundary area. So a little wrap up of this analysis. We can say that based on the first test, these higher non-numbers don't affect the actual boundary area and the placement of these zones. Whereas in test 2, because we dealt with a negative value, it would push these zones away from each other, changing the layout itself, and the boundary area becomes greater as we decrease this value.
As Steelcase is continuing the improvement of their One Design software, we gave them some recommendations which they seemed very excited about. First, we recommended implementing some type of recognition algorithm for the boundaries of each layout. Also implement dimension standards for their One Design zone calculator. We recommended they use weighted matrices like the noise constraints and personnel flow, and also making it more user-friendly for their customers. Also, we want to have Steelcase not have the circulation area as a one zone, but implement it throughout all of the zones. And then finally, we want Steelcase to compare cost and adjacency. We would like to thank everyone for joining and listening today, and now we have time for any questions that you may have.
If anybody has any questions, please unmute your mic and ask away. Anyone have anything? Are we all set? Anybody? Well, we can't let this group get off so easy, so I'm going to ask a question. What's the square root of the moon? See, I stumped them already. Anybody have anything else for this group?
Dr. White, Dave Nall, I just typically in a project of this magnitude, there's maybe 1 or 2 kind of significant aha moments where, wow, you really stumbled upon something. But what would, from their perspectives, what would be that aha moment? What was the most significant aspect of the project from their perspective?
I think one of them was the Measure Square software that we found through research, because there was a primary issue with the dimensions of their floor plans and determining what those should be, and also that idea of image recognition and separating the floor plan by wall boundaries and open areas to perform that optimization in those empty spaces was very helpful in tailoring this generic software to each customer's specific floor plan layout.
Very good. Anyone else have anything for this group? All right then. Well, thank you very much.
Thank you guys. Great job.
Nice job.